Kevin LaFata, you are up presenting on the 3D printing basics.
All right. Well, howdy, everybody. Thanks for scooting over. I don't know what's going on with the other projector over there, but so well, right off the bat, I did not bring my 3D printer. I mean, there's a couple good reasons for that. Number one, it's here's a picture of it. So it's
just a little louder if you can.
What's that?
A little louder.
I can't. Sorry. If I talk any louder, I'll run out of voice by the end of the night. So I'll try to talk as loud as I can, but that's going to be about it. So that's the printer. I didn't want to bring that thing because it's about 40 pounds and about yay big off the ground, and as soon as you start moving those things around, they get out of alignment, and then and the worst thing is if I did print something while we were here, about the hour I've been up here talking, we'll print out maybe something about that big, so it's not really worth bringing it in. But I do have some videos and pictures, so that hopefully will cover it here. All right. So how many people have had some experience with 3D printing? I know a couple people have, at least, for sure. So, okay, so it's, I guess, kind of new to most people. The way that it works, and there's a couple different kind of printers out there, but the one I'm going to be kind of talking about is what they call like an extrusion printer, where you actually have some plastic that goes into a heater, and it just kind of spits it out, makes the object. Most printers have at least 4 motors on them, if not more. So you've got, the 3 dimensions. So you've got an X stepper motor that moves in one direction, Y goes that direction, Z goes up and down. Some of the printers have 2 Z motors, make it a little bit more stable, because it's sometimes lifting up a whole print bed or a whole, that whole device there can get kind of heavy and mess it up. And then finally you got another motor that actually feeds the filament through. So basically the filament is like it's like a strand of plastic that comes on a roll, and it feeds it through the top there. It goes into this heater and a really thin nozzle that kind of spits it out. So as all these 3-dimensional things are moving down there, it's spitting out the plastic filament and kind of building your object from the ground up. They do have other kind of printers that will, some of them are like liquid or powder, and they kind of build from the top down. So they'll start here, and there'll be some kind of light at the bottom. Oh, thank you. That's cool. Some kind of light at the bottom that solidifies that plastic or liquid, and it kind of pulls it up from the top. So on the printers I'm talking about, it builds it this way, but the other ones will kind of pull it out of the material as it comes up. There's some benefits and drawbacks of doing it either way, and I'll get into some of that in a little bit. So let's see. So yeah, and the other thing, there's a heater on there, and then there's also like a cooling fan. So you want the filament hot down here, but not hot up there, otherwise you run into some problems. And that's why a lot of them have fans to kind of keep certain areas of the print head cool, but not others. All right, so let's see. I have a video of one of these things in operation here. So hopefully this will work. Okay, so this is my printer at home printing out a box. I'm gonna pass around a few things to kind of show off too, but that's kind of it, building it from the bottom up. That's probably after about 5 hours worth of printing on that. So it just goes really, really slow, and you kind of see it just going, line by line and going from the bottom to the top there. So I'll tell you what, I'm going to pass out a few things here as we're talking, and let's see, what am I going to show off first? This guy here is basically one of the first things I printed, and it's kind of an example of something that didn't really work. If you kind of look at it, you'll notice that the walls on it are really thin, and that was kind of one of the built-in examples that came with the printer. let's see. Okay. So everybody always asks, what can you print with a 3D printer? I mean, there's a lot of things people know about, but then there's a lot of things that just kind of wild imagination. Whatever you can think of, you can probably print with a printer. Some examples. These would be like some pieces for. Let's see what I do with the pen. So like these guys would be like some pieces for some robotics. Putting together robots and stepper motors and things like that. That's some kind of model engine. Apparently that's like Caesar with a bunch of pencils stuck in his back, so it's like a Caesar pencil holder. You make some toys and mazes and things like that. That's like a microphone holder, so you can mount that on the wall and stick your microphone on it. Some of the things I like to print would be, when I first got this thing, I wanted to print out some puzzles. So this is like some kind of deal here where you try to get these things put together in a cube or whatever. I don't know if anybody's going to try to do that while we're here, but I'll pass these around. I think there's 6 pieces that make that up. And then this guy here is like a little round tube. It's like a 3D maze, and you kind of move this thing around and try to get yourself out of the maze there. So little fun thing to play around with there. All right, so generally you kind of classify things to print, like models, like you want to print out like a little Yoda model, or if you're into different movie characters or comic book characters or whatnot, you can always find that stuff online and print that kind of thing out. Functional prints, and somebody was asking me about this earlier, it's like if you've got something at home that just breaks, I've seen people where they got those side-by-side refrigerators where there's like a little piece in the middle that, that folds out when you close both doors. Sometimes that thing breaks up there. And I've heard of people printing out a brand new one, just putting it on there, and, you don't have to call the repairman out to get that fixed. You got utility prints. Like one of the things I wanted to do at home was I've got this. Want to hook my garage door up to the internet because, who doesn't, right? But in order for that to work, the device has to know if the garage door is open or closed, and, so you got little magnetic contacts. And, trying to get those on the track wasn't really easy, but when you got a 3D printer, you can make your own brackets that fit exactly where you want to put them, and makes it work out pretty well. Let's see, and then I got a couple YouTube videos here. There is a guy. Oh, here I'll bring this one up first. This is just some kind of random things that people have been printing out. I gotta get the. See if we can get that to come up. So this is basically a time lapse of a printer printing out a couple different objects. And basically what this does, every layer, the camera takes a snapshot of how it's gone. So this is, you kind of see that clock in the background to show you exactly how long some of that stuff's taken. And you kind of see how the inside of those isn't necessarily solid. And I'll get into that a little bit more later, but they call that fill. So when you're actually printing something out, you don't want to make a solid object. That just wastes a lot of material. Makes it heavier than it needs to be. So generally what you do is you print it out so it's structurally solid inside, but it's not totally solid plastic inside. I'm guessing, I think that's a Star Wars thing. I'm not really into Star Wars, but I think that's what that thing happens to be.
I was thinking Doom.
Doom? Okay, yeah, it could be. This is some kind of oddly shaped thing that actually rolls. So you put that together and kind of glues it, and it kind of rolls like a ball, but it's not shaped like a ball.
Why wouldn't you print that out as the altogether?
Well, I mean, there's some limitations when you're printing like that, and I'll get into that a little bit later too. But the trick is when you're printing, that plastic has to stick on top of something. So if you're printing and there's nothing underneath it, it's just going to shoot that plastic down onto the bed. And it's not going to. So you kind of have to be a little careful with how you print. But yeah, there's a million things out there that you never would have thought of to make a print of. And like this is going to be a bird, but I kind of find that interesting how down here it just kind of built up from both sides. So if you print it at the right angle, you'll be okay. But if it's any more of an angle, it's not going to work. Let's see if I can find, let's see. I don't know what that is either, but. Okay. But it's not just models and whatnot that you can print. There's a couple guys out there on YouTube. There's one thing on here I just found fascinating. This guy made his own, basically a 3D wire bending machine. And basically what he did was he printed out some 3D parts and hooked it up to an Arduino and just whatever, and just made this crazy contraption here that, if you ever wanted a wire bending machine or anything like that, I mean, it's just really.
It's actually a fractal antenna.
What's that?
That's a fractal antenna.
That's a fractal antenna.
Ham radio applications.
Well, we'll get into a few ham radio applications too, but if you're into like project building, I mean, some of this stuff is just kind of crazy. He basically goes through all the steps that he needed to make this thing, the gears, how to put them together, how to hook up the motors. I'm sure this isn't his first try at it because, I mean, you can't just come up with this and have something work right out of the box like that, but he actually goes into designing his own circuit boards and getting them printed and program the Arduino and, basically getting everything working. But yeah. There's a guy that makes his own radio control models with like jet propeller engines on them and some kind of tank device that he makes that goes on the water. All kinds of crazy stuff. All right, so there's the wire bender project. Okay, so this is what the material looks like that you print. It usually comes on a spool, comes in a bunch of different colors. Sometimes you get multiple colors on a spool that changes from one to the other. You can pick whatever color you want, obviously. And they call that PLA. I don't remember what it stands for necessarily, but it's a type of plastic. And right now, that's kind of the material that most people would recommend for most of the types of prints that anybody would do. I believe ABS was one of the original ones, and they still make that. And I think in some cases it's a little bit stronger, so you can use it in some circumstances. And then they have specialty filaments too. Like you can get glow in the dark filament that's cut carbon fibers in there.
But this all depends on your printer, too, right?
Most printers can handle these. They're made to go through the extrusion printers or whatever. Sometimes you have to adjust the temperature for the different materials, but other than that, most of these are compatible with the standard extrusion printers that are out there.
Some very inexpensive printers will only do PLA.
Is that okay? Okay.
And the problem is that like ABS and some of the others shrink as it cools down, and it will actually pull off the bed while it's building.
Oh, yeah.
So to fix that, there's a heater that's in that printer plate that's there. Cheap printers don't have a heater, and so they can't handle any plastic that warps. So that limits them to just PLA.
Right. Yeah, and you'll run into some issues. Yeah, there's plenty of issues you run into when you do 3D printing, and having a warped print is definitely one of them. Even with a heated bed, I've had some prints that were pretty long and flat to start off with, and then after a while, one end just kind of curves up, and that just completely messes it up. So this is something I printed with like flexible PLA. I'll pass that around. It's sort of flexible. So like I said, they make different materials. They even make filament that's got wood in it. So when you print it out, it sort of looks like a piece of wood that you've carved out. Color changing that changes its color with the temperature. And then this guy here was trying to demo like a copper-based filament, and the one on the left here I think is how it came out of the printer, and the one on the right is after he kind of tumbled it in a rock tumbler with I don't know if he had copper screws or brass screws in there or something, but somehow he ended up making it kind of shinier that it actually looks like copper. All right. Okay, so here's a couple issues that you might run into. These are definitely ones I've run into where this guy here, I don't know if you can tell, that's kind of fatter down here on the end. For about a month, I was trying to do some prints, and it would print for about an hour or two, and then it would just stop. Nothing would come out of the nozzle. And it turned out one of the fans was broken. They cooled off the top of the print head. So what it would do is it would get down there and melt, and then it would just kind of get stuck, and then it wouldn't come out after a while. This guy over here, I don't know if you can kind of see how it's thicker on the top and barely visible on the bottom. That's one of the reasons I didn't want to bring the printer, because one of the major things you have to do is you have to get that bed very, very level when you're starting off a print, because it's got to stick to something to build up on, on the future layers or whatever. So everything really, really matters on how that first layer gets printed. And if your bed's not level, then that filament doesn't stick to it right. And as you go further and further, things just get worse and worse over time. So it's super critical that I think some printers do their own bed leveling, and some of them you have to do it manually, but you've got to get that down to the 1/10 of a millimeter to get that right. But once it's set, it's great. And then the other problem is sometimes you end up with spaghetti, So go ahead.
On the previous slide,
Uh-huh.
where it stops printing after about an hour, and you said it was one of the fans wasn't working correctly.
Uh-huh.
How do you determine which one is the parent, or do you have to send it off to the manufacturer?
A lot of printers are made that you can work on them yourself, and I didn't even notice it until somebody on Facebook said, "Hey, check your blah 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 fan or whatever," and I looked at it and I could tell it wasn't spinning. So I just went online and ordered. It was like a 10 centimeter fan or something like that, and you just take the old one out and put the new one in there, and it'll work fine after that. There's been times, I think sometimes it's if you let your filament get too what's the word? It's supposed to be dry. So if it gets a lot of humidity in it, sometimes the moisture will clog up the nozzle too, and I think that's been a problem every now and then. But yeah, and if you do have something where something doesn't stick or something gets out of whack, and all of a sudden you come back 3 hours later and you've got that sitting on your printer, or all over the floor or whatever, that's basically that's just a waste of time and money when that happens. So generally, to keep that kind of stuff from happening, there's I wouldn't call it a program, but it's a I don't know how to explain it. I'll pass this around to you because that's kind of what I'm running on here. But there's a system called OCTOPRINT, which it runs on a Raspberry Pi. I've got one on this. It's a Raspberry Pi Zero with Wi-Fi, and it's got a camera on the back here. And basically, this thing just plugs in your printer, and you point the camera at your print bed, and it runs like a little web server on there where you can actually log in from anywhere and see what's going on, and it takes pictures of every layer, and it's also got like a live view camera on there. And if you're going to do any kind of 3D printing, this definitely recommended to get something like, put something like that on there so you can monitor it, turn it off, all kinds of controls or whatever. Because normally, let's see, usually, I guess on most printers, if you don't have something like this, you've got to put the print file onto an SD card, and then you got to stick the SD card in your printer, and you got to select the file, hit the print button, and then it just kind of runs. But with this, it's like a print server, like I'm going to send a file to the laser printer. I'm just going to send a file to the 3D printer, and so it works more like a network printer in that case. Let's see. Yeah, and you can queue up multiple files on there. It'll kind of give you an idea of how long you got left on your print, that kind of stuff. So. All right. Okay, and that kind of gets into the whole filming of a 3D printing. We kind of watched a video before of a camera that was doing that. There's a guy on Reddit, which I don't know if I can bring this up or not. If I can connect up to the old internet here. Basically, there's a guy who made a device that sits on his printer and kind of moves a little camera around, so he's got a little bit fancier camera movements on there. And we get this to come up. Any questions so far? No? Okay. Oh, yeah. Cliff's got one.
The things that have been passed around, they're all very rigid. Are there different levels of quality or softness, hardness?
Kind of, yeah. There should be like a little green thing going around that's flexible.
Right there.
Yeah. But most of the stuff is pretty rigid.
Yeah. So there's levels of quality based on what you're making, right?
I don't know if there's a whole lot of levels. I mean, it's usually pretty rigid. Then you've got a flexible one, and that's, yeah, I don't know if there's a lot of in between there, but, yeah.
Yeah, Kevin, I see this white one here is almost like a styrofoam.
Yeah, that.
But the puzzle pieces, I guess, the purple ones are kind of like very smooth.
They're solid, yeah. That white one is basically the first thing I ever printed, and that was before I had it adjusted. So I basically had a couple settings out of whack, so it wasn't putting out as much plastic as it should have, and you end up with a little bit that's something really flimsy, I guess. And
Yeah, it feels like styrofoam water setting.
yeah. Yeah.
Do you need gravity to be present, or can you do these in space like an ISS?
Okay, I'm sorry.
Do you need gravity to be present, or can you do this in a weightless environment?
I don't know. I don't have a weightless environment to try it out in.
They have a 3D printer on the space station.
I guess
Yeah.
And I would assume that you don't need gravity because you've got the extruder that is pushing the filament out of the hot end.
Yep.
So, and the distance between the nozzle and the top of your print is
Oh,
a
pass that
fraction
around
of a
too.
millimeter. Okay, so each one of these layers, it's like a whenever you take a balloon and you squish it, it looks like that. So I would
Yeah.
assume that, I mean, they've got one on the space station, so I guess it works in 0 Gs, but yeah, it pushes the filament, and then as the hot end is pushing the filament, or putting the filament on the level, there's a fan that is blowing on the object that you're printing, and it instantly cools it.
Right. And I guess the next time it goes around, it's heating up not only the filament that's coming out, but the layer it's sticking to. So it's got to make sure that gets hot enough to get them to stick together.
So two other comments about that. One being a former submariner, and one you wouldn't think about with the space shuttle. it's not gravity that would be a concern in the space shuttle. It's the evaporating of the plastic and messing up the atmosphere. And on a submarine, that was one thing that was always a concern, was keeping your air clean and not having things pollute the air. That will happen if you use any of the plastics. You will notice while it's printing a hot odor of the plastic. So that's something to think about with that. And then the other one, which hasn't come up yet, I hope I'm not stealing your thunder. I don't know if you're going to say it or not. Every one of these examples here probably costs less than 10 cents to print. Okay, the plastic spool will cost maybe 20 bucks, but you can go a long, long time and print a whole lot of stuff off of a spool of plastic.
Yeah, the spool is what, about a kilo? Is it a kilogram?
Yeah, a kilogram, which is 2.2 pounds. So that is a tremendous amount. You can get a lot for the spool.
Is there any way
Yeah.
to use it after you've messed up? 'Cause
Nope.
that seems like
Yeah.
Yep.
I've seen people recycle that stuff, but I don't know how well it would work. I mean, you'd have to.
How long did it take to make the puzzle piece, the purple and white?
Oh man, that was probably 6 hours maybe.
6 hours.
Yeah.
But that's 6 hours, you just leave it, let it run.
Right. And,
You
well,
don't
you
have to stand there.
don't have to stand there, but I did check on it, and honestly, if I print something that's going overnight, somehow I wake up in the middle of the night and I check on it because I get nervous. Yeah.
Did you create the design for that piece?
No. There's only one thing I designed myself. I'll show that in a minute, but.
Hey, Larry, there's also a study out that there is a noticeable, well, the ABS filament puts out a horrible odor. That's the one you have to keep hot. And typically people create an enclosure and do that, but there's studies. This is PLA, and I'll pass this around whenever we get to the ham. This is a Raspberry Pi, got a dipole and a keyer. But I just saw an article today. The jury is still out on the flame or the odor that it's created whenever you're melting this plastic, if it causes cancer or not. So, I wouldn't inhale all of the odor, but there was an article on like if you watch over, it doesn't stink, but you can smell it whenever it's extruding, and so just keep that in mind. Probably, me being, probably one of the younger people here, I probably don't want to inhale most of it, or I won't be present for you. But there is that. So.
In other words, you need to bin it. Sort of
Well,
like
I have it in my basement, and it's fine. It's not like it fills my house. Like, that kid's 3D printing, But the ABS, yes, it
Put in
stinks.
the bathroom.
I'm old,
Yeah, that would probably be
fishing weights and stuff.
something to.
Yeah,
You're in more trouble than he is.
yeah.
No, I bin it when I do it.
Was there another question over here?
What kind of melting point do these plastic pieces have?
Oh, somewhere around 200, 210 Celsius is kind of the.
They're pretty resilient.
It's pretty hot.
380 degrees Fahrenheit.
Yeah. You don't want to touch it.
Say it again?
380 Fahrenheit.
Did you have a question? I thought I saw somebody else. Okay. All right. So this guy made this little device that kind of sits on top of his printer, and it kind of moves back and forth and takes, snapshots of that. So that's kind of what it would look like after you run it. So yeah, all kinds of fancy things out there. It's kind of funny that most people's 3D prints are just more additions for their 3D printers, but yeah. And one of the things I was going to say early on was most of the stuff I was originally going to say most of this is just for prototype. You're not going to make any money printing 3D objects, but then I heard a story of somebody that's in here right now that probably is making some money on 3D prints. So I won't say that, but just based on the amount of time it takes to print things, it's not an easy thing to mass produce, I guess. Okay, so if you want to make something yourself, here's kind of how you would do it. The first idea is you'd use a CAD program to design the actual object itself, and I'll show a demo of that here at the end. Generally, like you'd use like AutoCAD. I think Fusion 3D is actually a AutoCAD program or whatever. And basically that generates a solid three-dimensional object, which ends up as an STL file. If you were to go out like online, there's a website called Thingiverse, I think is what it's called. And I don't know if I have that up, but you can actually go out there and people just put their objects online out there. So you can do a search. There's, I don't know how many things are out there, but hundreds of thousands of objects you can download and put on there. And these usually come down as STL files. So if
you get printers from different companies, most of them will run the same program. It's just
not yet. We'll get there. There's more steps.
Okay.
But so an STL file basically defines a solid object. You can't really do anything with that with the printer yet, because there's a couple more steps you got to go through. Basically, what you have to do is you got to take that STL file and run it through another piece of software called the slicer. And the slicer takes the solid object and basically turns it into the commands that your printer is going to understand. So, the printer only knows, move the X motor this direction that fast, or move the Y motor that direction, or extrude a little bit of plastic, or turn the heat bed up to a certain amount or whatever. And that's kind of what the slicer does. So that's a pretty important step, because what I'm going to show you here in a minute is there's a couple things you got to do to a 3D object before you can actually print it. Otherwise, like let's say you've got I'll step into it real quick here, but it's basically you're gonna size it. You might need to flip it around. You might need to change a solid piece into something that's just kind of filled with structural material as opposed to a piece of solid plastic. You might need to do like a raft, which kind of keeps it off your print bed a little bit if it's not completely flat on the bottom. Or if it's got something that's got an overhang, you need basically support structures. So if you've got I think this next one, like if you've got something like this, it's got a lot of overhangs on there. So in order to keep the printer from just spitting plastic down to the thing, you need to actually build something up from another place on the bottom, so it's got a place to, put the plastic on top of or whatever. So that's kind of what the slicer does that, and a few other things too. Go back here. Okay, so if you do plan on making things, I would recommend to get one of these things. Basically, a digital caliper. They sell them on Amazon, $20. It's before I got that, I would try to measure stuff with a ruler, and it was just, if you're trying to measure like screw holes on circuit boards and things like that, you're just not going to get accurate enough unless you're using something that can go down to a tenth or a hundredth of a millimeter. And that's been invaluable. Best $20 I spent on printing materials there. Okay, so if we start from the design program. So one of the programs I would recommend, there's probably a bunch of good ones out there, but this is the one I've been using. It's called Fusion 3D, or Fusion 360. Sorry, I'm going to start it up because it's going to take a minute to start here. But basically, this is something that AutoCAD puts out, and it's a pretty full-featured program that people pay a lot of money for to use. Fortunately, they've got a program out there for students or educational users, and you basically just go out to their website, you fill out a form, you put your name, your email address in there, You basically make a statement that says, I'm not gonna make more than $100,000 a year off printing stuff using your software, and they'll give you basically a free license for it. If you're making more than $100,000 a year printing things, you could probably shell out the money and buy it, but but my impression is it's not a cheap program. It's probably, what,
$500.
is it 500? I thought it was more than that. Okay, well, it's not too bad. If you're making $100,000 a year printing, 500 bucks. 500 a year. Okay, so that's basically 0.05% of your income if you're making 100,000 a year, I guess, on it. Okay, so we're still waiting for Fusion to come up here. And I'm just going to go through a real brief example of just making a stupid little 3D object or whatever. I'm not going to try to make anything fancy. Otherwise, we'll be here all night. But I could probably show a video of a guy that's actually knows what he's doing here. So basically what this guy is doing here is he's making a couple 3D objects using Fusion 360, and he's using a feature in there where you can actually kind of integrate and tell Fusion 3D how these objects fit together, so it kind of models it in the real world. So, right now he's just dragging these things around and they'll go anywhere, but you can kind of tell it that rod goes in the hole there, and Fusion 3D will make sure that stays in there. So if you move a part around, it's going to make sure they stay attached. And ultimately, he ends up making I don't know what this thing going to end up being, but
Part of a gun.
What's that?
Part of a gun.
Probably.
You're making that plastic not a very good one.
Yeah, and you probably could. I'm sure you could find the 3D gun out there somewhere. I mean, once it's on the internet, it never comes off the internet.
Making parts for an AR-15 on there. These kids were putting on it.
But while we're waiting for that to start, I'll pass around a couple more things here. This is basically something I learned how to do using this software on YouTube, and it's basically a box that snaps together, and the top piece has got some like little V's in here, and the bottom piece has got like a part for them to snap into. And basically, you define this thing as a box in Fusion, and then you kind of cut into it, and then you end up with two parts, and then you print the two parts, and it comes out so that they fit together pretty good. I'm not going to snap it together because it goes together pretty tight, but if you do, you might need a pocket knife to get it apart. And this is basically another one. This one you can snap together. It'll come apart, but this is basically a kind of what I call a failed print. You'll kind of see that it's really, really thin and flimsy on the walls and kind of coming apart, and the top is all messed up and stuff. But I'll show the finished version of this a little bit later. And by the way, that thing is supposed to be something Kyle and I were working on. Would be like it's like a Raspberry Pi TNC. It's like an APRS repeater. So it's basically a Raspberry Pi with another board on top, and needed to make a case to hold all that. And that's not something you can just buy in the store as a case to hold something custom like that. So that was going to be the project du jour for trying to print something out.
How long would it take to make one of these?
That was probably maybe 2 or 3 hours to print. To design it was probably about an hour of messing around in there, trying to figure it out.
It'll take you 3 hours to try to find it.
Yeah, and that's the thing. You don't really get to test it out until it's done printing. So that's you gotta have a lot of patience when you're doing that. Okay, so here's the Fusion 3D program, and a couple things I've been trying to print out, a couple things I've experimented with. I got this thing right here, actually. At one point, I was trying to play around with the threading, which you can make in Fusion 3D. So it's basically you create two objects that can kind of screw together, and that's kind of what this ended up being. Pass that around, and this little guy here, I don't know if you can everybody see that, but it's got a little plastic screw that screws into one of these holes here. And I made 6 different size holes to try to figure out what size hole would hold the screw properly or whatever. Now I can't find it again, but pass those around. And I think those are actually on here somewhere. There's my garage door brackets. And
Clear plastic?
what's that?
Can you print clear plastic?
I haven't done anything with clear plastic yet, but and here's the little screw deal
Can
here.
it be done?
I think there's clear plastic. I would imagine they would have something like that. Okay. So I'll open up the. Uh-oh. Here, I'll get it. Got it? Okay. Don't lose that. That's very important.
Did you get it? I got it, thank you.
Okay. So we're dealing with a slow laptop here. Strangely enough, 3D modeling takes up a lot of CPU, if you can believe that. Any other questions while we're waiting on this, or?
What's the cost for them and versus the dimensions that you can print?
Well, different printers have different dimensions. I'm using basically something called a CR10, which is one of the bigger ones, but it's also one of the cheaper ones because it's comes out of China. So it's like 300 by 300 by 400 centimeters. So.
So like these boxes were no challenge for it.
What's that?
These boxes were no challenge for it physically.
No. You would be able to print out. I would say probably something about that tall on it. I've never tried to go that big because
And that goes for what, 2,000?
I think it was about 200 or 300. I think. Yeah. It was. Yeah. It was. The one I got had a couple extra features to it. It had like 2 Z-axis motors and a couple other things on there that don't normally come with it. So it might have been 400, but how much was the I don't even know how to say it.
The Prusa kit is $7.99. You can get it built in the Czech Republic for $8.50.
Okay. So yeah, a lot of them you have to put together yourself.
Yeah, it took me about 11 hours to put 10 to 11 hours to put mine together.
Okay. Yeah, I would say the CR10 it was probably 3 hours to put it together. It wasn't too bad. It was just snapping together some brackets and putting the belts on and stuff like that. Okay, so here is one of the projects I was working on here. And
How long did it take you to become comfortable?
how to become comfortable?
Just comfortable making something.
This is really basic. I mean, compared to what I've seen people make, this is nothing. I mean, people can make this software dance. I'm not one of them, but.
But to make something, some of the stuff you're passing around, how long did it take you to become comfortable? You get this new toy and all of this.
It's a lot of experimenting. That's all I can say about it.
A lot of mistakes.
You do make a lot of mistakes, yeah. I brought a lot of them I brought with me, but some of them are still sitting at home, and I don't throw them away. I like to keep them out just to remind myself of what got messed up before.
It's not for someone who's got ADD.
Yeah.
But the other one that I would say with this too is when you make mistakes, you're still having fun.
Right. Yeah, I don't think there's such thing as a plug and play 3D printer.
So,
Yeah.
if you weren't doing the design, if you were just downloading a project, how long is it, what's the startup time to be able to start printing a project you download?
You would download the STL file, you'd run it through a slicer, either like something called Cura or I use something called Simplify 3D, which are both pretty good slicers. Most of the time, if you download something off like Thingiverse, those are pretty well debugged objects. I mean, it's not gonna mess up the prints too much because people have kind of perfected them before they put them out there. So yeah, a couple hours probably, a couple hours of playing around with it and making sure everything's leveled, making sure everything is plugged in and set up right. And how long was it before your first print?
It took me a day to get my bed level and everything correct. But keep in mind, there's I don't know if you're going to go into this. You're going to go into different nozzles.
Yeah, I wasn't thinking.
So there's a standard nozzle that kind of all the 3D printers come with. It's a 0.4 millimeter, right? So I'll pass this around. This is done on a 0.4 millimeter, but you can go all the way up to a 1 millimeter nozzle. And so this takes, this is the detail on this is very fine because it's got a very fine nozzle, right? You go to a 1 millimeter nozzle and it's going to not be very detailed, but you're going to get your prints out quicker. So this thing took about 3 hours to print. If you printed it with a 1 millimeter nozzle, it'd probably take 30 minutes. But your detail would not be as great, right? So
yeah, and this.
So there's a balance there, right?
Yeah.
Some people say, well, a 0.25 or a 0.4 is too fine for me. I'm going to use a 0.6 or a 0.8, and they just sacrifice that detail, but they churn out the prints every, quickly.
So that goes back to playing with it a little bit and seeing that, hey, this works, or
And some PLA or some PETG works better with different nozzles. You have to get to know your printer.
Yeah, that's true. And by the way, that's 0.6 that I'm passing around. Yours is 0.4, so it's going to be, yeah. So you'll probably see the difference in the, you'll see the little, kind of where the lines are on it or whatever. So this is basically the case that I've been working on, and you can kind of see it's in two parts. I can with this program I can turn, I can turn like the lid on and off and just work on the cover or whatever. Man, that's slow. Okay, so here's like the bottom piece to it, and I'll pass around the finished project here. And for today, I kind of left the. I'll talk about this here in a minute, but there's the support material that's on here still that kind of goes over where the cutouts are, and I also left the raft on here, which is something that basically this piece is stuck down here on the print bed, and you kind of peel it off and kind of keeps this a little smoother underneath. So I haven't taken this off yet, but you can kind of look at it through the bottom or peel it off. I don't care. It's going to come off after night anyway, but so this is kind of screwed onto the bottom here. All right. So once these two, actually I don't want to turn this on because I'm afraid I'm going to blow up the laptop, but you can actually download a model of a Raspberry Pi, so you know where all the screw holes are and stuff like that. So you can have that in there and build your project case around that.
And then you just exclude that from print, right? And then you just exclude that from printed, right?
But I didn't. What's that again?
Just exclude that when you print it.
The
Raspberry Pi.
Yeah.
You said you could download it.
You download the
right.
the model of it.
Exclude that when you go to print it.
Yeah. Or you might end up printing out something in plastic that looks like a Raspberry Pi. It just doesn't work. It's just plastic. But yeah, it probably would try to print it if you left that in there. So basically from here you end up with you'll actually end up with two STL files. You'll end up with one for the top and one for the bottom. And then from here you'll take it into the slicer. And I think I had the slicer running.
That's what it looks like to me.
Okay, so we're waiting for this to come up. Any more questions? Okay, well, this will come up eventually. Okay, here we go. Okay, so this is a program, or one of a couple programs you could use to take your STL object and make a file that the 3D printer is going to understand. So basically what I would do is I'd pull something into here, and this is going to go really, really slow. Okay, open file.
Yes.
You can kind of see up here that you select what printer you have, and it kind of puts in some basic settings for it over here. Then you've got your layer height, which is, again, how much do you want the z-axis to step up for every layer. Come on. This is crawling. Okay, so I'm going to take this guy here, which is another puzzle box. What's that? Huh, what?
How'd you do the threads, Kevin?
How did I do the what?
The threads in the purple.
On the box.
Oh, yeah.
The thread's done on the inside.
There's actually a function in Fusion 3D where you can take a cylinder and just add threads to it. You can tell it like how far you want them spaced, or how, what type of, how deep they go. And, it just works. It's one of those things.
It's just going to create the threads as it's layering up.
Yep.
Wow.
I was like.
Complex. That is complex. Man.
Yeah, I was surprised that worked. Okay, so here's an object. Man, this is slow. Okay. So right now it kind of shows what it would look like on the print bed, and.
So that block just came out with threads already.
Exactly. Yeah. The one with the. Right. Yeah. You specify like. I'm trying to think. Usually like when you got a screw, it's like a 10 or a 12 or something like that. Yeah. You tell it on there. Right. Yeah. And actually in Fusion 3D you can actually. Yeah. Yeah, you can download like actual parts from like McMaster Car into Fusion 3D, like a screw or a nut or something. Import that model in there, and then generate your part around that too. So all the really common stuff is out there. So if you're planning on using like a special kind of bearing or something like that, you'll be able to probably pull that right in and just have everything measured exactly how you want it without having to guess at it.
That probably comes with playing and having a few oops.
Yeah, you want as few oops as possible. Generally, you saw one of the boxes I printed. Basically, after I took that print, I noticed 4 things I wanted to change on it. So you kind of work from your mistakes.
So that file that you created, that box with the threads.
That
was a big file, wasn't it? The program.
I don't remember it being that big. No.
Really?
Yeah. Yeah, you could probably. If you go to YouTube and say Fusion 3D or Fusion 360 threads, there's probably a few. You'll probably find 10 videos about how to do it, and it's pretty simple.
I'm just thinking the math that's involved in doing that.
Well, they do it for you. Yeah, it's pretty. I thought it was pretty impressive.
You showed us.
Oh yeah, I've spent countless hours watching TV, screwing and unscrewing that thing, just playing with it, And
that's amazing. It just comes right out of there, done. You can just, you don't have to thread it.
Yeah, and I lost my train of thought on that, but
Hey, you can really make some things quick that way.
So in the slicer, this is the program where you use to tell it basically, how fast do you want it to print, how how thick is your nozzle, how sturdy do you want it, how much infill do you want to put in there.
Besides taking more time, is there a disadvantage for taking more time?
Yeah, I mean, here's the thing. If you do like a layer height of I don't know, say 0.2 versus 1 millimeter, you're talking a difference between like 2 hours and 12 hours. So there's a pretty big difference when you start adjusting some of that stuff as far as how long it's going to take to print. I mean, it's significant. I mean, depends on how fine a detail you want. If you're printing out like say a garage door bracket, you don't care if it looks, if it's got lines in it or not. But if you're printing out some kind of comic book character that you're going to, paint a little bit, do something with later, you probably want it to look a little bit nicer.
You ever do a prototype first with a bigger dimension and then make it smaller? Use smaller?
If you're coming up with something from scratch and you're going to want to do that, yeah, it's probably best to see how it looks by, making a rough draft of it, I guess. Okay, so basically once this thing's in here and you've got all your settings, you may want to generate support. Infill is basically how much plastic do you want to use on the solid areas. So if you've got a solid object and your infill is 20%, it's going to generate like a crisscross pattern that only uses 20% to fill up that space, but it's still pretty solid. You never actually ever see it. Once it's printed, it's all inside of something else. People say you can do 100%, but they said it's not really any less solid than a 20% infill. Yeah, and if you do solid, it's definitely going to take way longer than if you're doing some kind of infill. So once it's in here and you click the prepare button, this is where it actually generates something called G code, which is what the printer understands. And at some point it's gonna.
Ready to save to file.
Yeah. So something like this with those settings take about 2 hours and 43 minutes. And let's see. I think in a lot of these programs you can actually show how the layers are going to work too. So it can like step you through exactly how the printer is going to print this thing out. Before you do it. So it's coming up now, I guess. So basically saying this is about 400 layers long, and basically the first thing it does, it puts that raft on the bottom, so it's not exactly sitting on the bottom of the print bed, and it kind of goes up from there. So I can zoom in on a little bit of that. So you can see exactly where it's gonna put plastic when it builds this thing up. And originally this thing was like a maze, so you can kind of see how it's generating those little pieces of the maze as it builds it up.
And the program all does that. You don't have to figure out any of that.
Thank God you don't. That's all I can say, because some of that stuff would be really complicated. Maybe in the old days, I guess, but
the old days.
The old days, yeah. The old days of 3D printing, back when your grandparents were making 3D objects.
Yeah.
They had to do all these calculations manually with the slide rule and all that. But yeah, so most of these programs are smart enough to know that anything that overhangs at more than a 45-degree angle is going to need something holding it up. So if that happens, it's going to start building something from the bottom, and by the time you get to that point, it's going to have something to rest on there.
Kevin, how much current does the printer draw?
How much current?
Electric current, does it?
I'll tell you what, most of them have a heated print bed, so that thing gets up to about generally like 60 or 65 degrees Celsius, and that's got to stay hot the whole time. So if you're printing, a 14-hour print, that thing is on the entire time. The print head 200, 210 Celsius. So I would imagine it uses up a pretty good amount of electricity.
So it's not as much as you think. Minus 120 watts.
Okay, it's like a good light bulb or two, yeah, at least.
A two-head printer at one point, it used 150.
Right. I mean, it's more than like an inkjet printer would use, but yeah.
So you said the print bed had to be hot the whole time. If you're doing something that, stacking up, why does that bed still need to stay warm?
I'm not 100% sure. Does anybody know the answer to that?
Because if it cools, the whole part will come off of the bed.
Yeah.
Okay, that would be a problem. Thanks.
Yeah.
Yeah, so try that sometime. Get halfway through a very long print and turn off the bed heater.
Mine don't ever seem like they would come off because I always have a hard time getting them to come off there even after I turn it off.
Well, okay, you're lucky.
Whenever they first did this, it was. I lost my thought. Yeah.
I think, because they do make them such that they're like in a container too, so that the whole interior stays warm, and that's also to keep your material from warping a little bit.
Yeah, that's where I was going with it. Is if you don't and it cools, you can get that warping. Yeah, okay. I've had many prints like that Raspberry Pi box that the flanges on the end where the screw holes are, those will curl up because it just doesn't, right? So it's you want it to stick to your print bed, but I know where I was going with this. So back on the early days, they didn't have very good print beds, and you had to keep it hot to keep it stuck. Now, John and I have Prusas, and they have a print bed that you can get it powder coated, or you can get this metal print bed. And once you put that first layer down, and the first layer is the key, right? So Kevin said, as long as you get that first layer down, that thing is stuck to that bed. And I bet you I could probably cool it down to probably 40 degrees or 30 degrees. It would probably stick because they've made some advances in those peak or those what you print on to really make it stick. A lot of people print on glass. That is a good thing to print on.
Yeah.
Yep.
Yeah, that's what I usually use, glass, and to get it to stick a little bit better, I'll put down like a glue stick and rub it on there just to kind of make sure that it really grabs on there, because last thing you want is your print coming off while it's printing, because that just completely ruins it. But
I know after I get done with the print, I mean, you take it off of that sheet and it's on there. I mean, you gotta really flex it to get it off, and it pops right up.
yeah, here's this is basically this object here. It was something I thought I could make. It's pretty big. It ends up being about this big, and it was supposed to go over a big old 12-volt marine battery to keep me from shorting it out or whatever. And that thing about halfway through, at the end, like half of it just started curling up off the bottom of the bed. And so that one didn't work out too well. But so let's see. Yeah, okay. So these are that screw and thread thing here. I tried to make like I don't know, what do you want to call it, like a plastic bag dispenser where you put the plastic bags in the top and the polio ones out of the bottom, and I wanted to make it so that they screwed together so I could make it arbitrarily long or whatever. But all right, so we got to talk about some ham radio stuff too, I guess, since this is since we're actually at a ham radio meeting. And come on. I think I overloaded the laptop. Okay. Well, I guess one other quick thing to point out too is a lot of these slicer programs give you like really fine control over what you're doing. So basically you could say, I want to print the first 3 layers very, very slow so that everything sticks, and then, the next 100 layers speed it up a little bit, and then maybe the last couple layers you slow down. So they give you that kind of control over your prints, and in some cases you might want to do that. Same thing with the heat. You can also say when you're printing the first 10 layers, make sure the bed's at 65 degrees, but then after that you can lower it down to like 50 degrees or something, just to,
Can you start and stop in the middle to change filament color?
On some printers you can, yeah. I don't think it's gonna work. I don't think it works on all of them, but like the CR10 has got an ability to do that. I think or can yours? Okay.
Yeah,
Some of the newer ones.
On the Prusa's, you can. It's you can do 5 filaments at one time, and what it does is it prints, and then whenever it changes the color of the filament or whatever you want to start printing with, it'll go to a part in the bed and just extract all of that filament right out of the nozzle.
Cleans the nozzle out.
And it figures out, you put it in a sensor and it figures out, okay, I'm running on new filament, and then it'll stop, and then it'll start again with the new filament.
Well, that top left picture on the screen right now is one that nearly any printer can do, and it was printed probably 80% with black plastic, and then they switched to the yellow to do the detail setting on top of it.
Yeah, so as far as ham radio stuff goes, there's probably a million things you can print with that too, but just as some starter ideas, if you want a little logo. Kyle passed around another one of the, well, it wasn't quite that one, but it was similar to that.
Yeah, that's the baby brother, it's the big one.
Yeah. Or you could just have a single key one. This is actually, I think some of the other radios have kind of like a slope profile on them, so that'd be like a little stand you could put it on to even it out. This would be to use, like, if you're going to make a loading coil, you can kind of wrap your wire around that, and since it's plastic, it's probably not going to interfere with the actual coil itself. That is it's like a scaffold for, I guess, a helical antenna. Anybody know what kind of antenna that is?
Batwing.
What's that?
A batwing.
Okay, so somebody made some kind of scaffolding where you can actually make something along the lines of that too. So, okay, well, we did the demos of Fusion, and I think, let me see if I had anything left that I forgot here. Okay, I did have a couple other examples of some bad prints here. Here's another one where it didn't quite stick to the bed all the way. Starting off one of those. Let's see. Dun, dun, dun. Okay, and I guess that's another one of just it printing out the couple pieces we were looking at. So anyway, that's kind of about it. If anybody has any more any questions, maybe I can answer them, or maybe those guys can answer them.
Can I drive for a minute?
Can you drive? Yeah, but
Your computer?
good luck. Yeah.
Ham radio examples, I can-
Sure.
Just go to Thingiverse.
Yeah, it should be up already.
George's got a question over here.
George, where's George? Oh yeah, what's up, George?
Yeah, on those items that had the thread, did you have to do like any cleanup? Did you like sand those or?
No, they came out just like that. I mean, I was like super surprised at how they came out. So.
I would be too. I mean, this is.
I mean, I made the little screw thing first, and it's like, well, that turned out so well.
What kind of software are they using?
That's that Fusion 360.
That's pretty complex.
Man, that has blown your mind, man. you are just taken back by that.
That's why. You make this, and I'm watching it. It goes. You make it, and it just forms those threads.
Well, yeah. If you try to calculate how to make like 3D triangular or whatever you need to make an object out of something that goes in a spiral, yeah, it would be complicated.
think
For
about, I mean, I
Christmas,
guess
make him a
if you were
screw.
watching, well, it would be neat to see this being made slowly, but speed it up. This would be incredible.
Well, next time I do one of these, I'll make a video of one of those print out. Oh.
For a beginner
Mm-hmm.
that is not an engineering background, is it better to get one of the open air ones like you were showing, or one that's totally already put together, cube things?
I would say they're not super difficult. I mean, the one Kyle got's probably a little more complex to put together. The CR10, it's just some brackets and screws, and it really wasn't that technically challenging to put together.
On display.
Do they have the CR10s at Micro Center?
I don't know what version they have printers there.
Yeah, well, there's some of theirs
The ones
were.
they have at Micro Center are expensive, and you're not going to get any better
Yeah.
results as a beginner than the $350 Creality that you buy from China. And honestly, if you want to stay under the $500 point, his printer's one of the best you can buy.
Can I change my Christmas request?
And
She's already changed it for you.
On this thing,
Yeah,
that's
it's cool.
amazing.
Now you're locked in by
It is, without a doubt.
So what are you saying? You like the threaded stuff?
I mean, it's not, if you look at a lathe and you can see the mechanics and say, it makes sense, easy enough, you drill it, you make and you cut and you make, you're right, to tap it, you make the whole thing, that makes sense.
You're taking things
But you're
away.
laying out and you're building this thing from the bottom up, and it's making it with the threads already.
I know.
That's mind-boggling.
That's
Not only
crazy.
that, you can make things you cannot machine.
Make him one for
You can make
Christmas.
things
What's that?
that are impossible
Make him a
to
screw for
machine.
Christmas.
Oh.
You can make a double helical sun gear, and it is impossible to do that on a lathe or on a milling machine.
Doesn't it also lay everything out in a straight line, or does it optimize the path?
The slicer knows kind of how to optimize paths a lot. So the newer ones are better at it. But yeah, they kind of.
This is why software engineers get paid the long dollars.
This would be beyond anything I could do. I do some financial stuff, but that's just nuts. Yeah.
Did you have something else you were going to show on the screen?
Yeah.
Yeah,
okay.
there are several things that I do with the 3D printer ham radio related, and I didn't bring any show and tell, so I thought I would just Thingiverse is a place where you put your designs to share with the world. And this is an adapter for the back end of a FT817 to use power pole.
That's great.
So the problem with the FT817 is this little barrel plug on the side here breaks all the time. And so people don't like it, and a lot of times they replace it. This, you just plug this on the back of it, and you've got a power pole on the back of your 817. I have sold over 3,000 of these. Okay, so I think I'm one of the rare people that can actually make money on, or have made money. And I just fell into it. I'm an 817 user, so it's like, hey, I like this thing. And then discovered that I could do it. So I've made adapters for KX3 radio. I'm a QRP guy, so that's the kind of stuff I do. This one's sort of cool, and you're seeing it here first. I will start putting these on the market. People who have KX2s complain about the tuning knob on them. That it's a very small radio, and the knob is very hard to tune. So I've designed one with a finger detent on it, and for the most part, it looks exactly the same as the other knobs on the KX2. So it's got that same look and feel. When I actually put these into production, I'll use a black plastic that's not glossy either. But that's what it looks like in the design. And
Quick question on your plug on the back. How many iterations did you go through before you got one that was a workable object?
So on the 817 adapter, I think it took 12 iterations to
12.
get to it.
Okay.
As I got smarter about it, I think it only took 4 iterations to get to this point on the tuning knob. And then as far as oh my gosh, you can do stuff that you can't do anyplace else with this. This is a mast bearing for a buddy pole. and it's actually printed all at once. Well, I shouldn't say that. There's actually 4 pieces in that fit together and lock in there to give the mast bearing. And a buddy pole is a portable antenna mast. So the problem with it is when you're trying to turn a dipole with the way that it comes from the factory, the guy wires on the mast get tangled up with it. So I designed this. Inside here, I know it's hard to see in the photo, but inside here there are bearings that are actually made out of airsoft pellets. So they're plastic. So this entire thing is plastic, but I guarantee you that this is stronger than the antenna mast. And then the other one is that it's a double row of bearings in there. It's not just a single row, so it can handle thrust or torsion from it won't wobble or pop the bearings because of having the double races. So
Wow.
and I think those are the only ham radio things that. See, I've got KX3. This is make this the last one.
Yeah, the really hard part is getting in that mindset of like, I need something, I could just go ahead and make it. You know, just realizing that you can do that in a lot of cases.
Oh, I've had ham guys that say, you know, a PL239, we need some covers, just dust covers on the end of an antenna cable connector, and it's like, oh, I can do that. That only took one iteration, and then I do it in that soft plastic, so it's flexible. And then I decided, oh, I need a little tab on the end of it, so I can put a lanyard on it, so that it, so
It doesn't get lost.
it doesn't get lost.
John, you should put that on Think of Ours.
Put what?
The dust cover.
Yeah, I probably should. I just never gotten around to it.
Should buy a
Honestly,
table.
the only things I put up here are things that I put on the market.
Should buy a table at Winterfest.
We can do that today.
There's another story there. I work with a charity that I committed that weekend, so we can't go. You need to have Winterfest a week earlier, and then I'd be able to be there.
Okay, cool. Anybody else have any more questions?
It's the story of the club.
November 0, Whiskey Lima.